As Lisa said, please don't take pictures, and especially don't upload them. I'm here to recap a bug with you, a network-wide bug that affected all or mostly all of the nodes in the Bitcoin network. The bug was in Bitcoin Core, and it's titled DoS to inf to send sets going too large. And if you don't know what inf to send sets are, yeah, stay around. Lisa already did a great introduction. Really briefly, I'm Timo, or B10C. I'm really interested in how the open and permissionless Bitcoin network is being used or abused by actors. I run a Bitcoin network operations collective called BNOC. More on that later. And I have multiple projects monitoring Bitcoin, the network or different parts of the Bitcoin network. So, for example, as Lisa mentioned, the mining pool observer, which shows transparency into what mining pools include in their blocks or what they don't include in their blocks. Also a project called Fork Observer, which is for monitoring forks, invalid blocks, stale blocks, and so on, and bigger reorgs or chain splits in Bitcoin. And then there is a project I've been working on over the last couple of years called Peer Observer, which is a tool and the infrastructure for monitoring the P2P network of Bitcoin for attacks and anomalies. And one of these anomalies I noticed while building out Peer Observer in early May 2023. So normally a Bitcoin Core node, once the inbound connection slots are filled, so peers connect to this node, and it fills up to a certain point where the inbound slots are filled. These usually remain filled until you either restart the node or the node loses network connectivity. But in early May 2023, I noticed on some Grafana dashboard I have set up that the current connections here in yellow, the inbound connections, started to drop over time. And they were dropping from around 190 to only 35 remaining in a span of 2 days. And this was quite alerting. Going on and investigating this and speaking with a few other developers, I noticed that the node had 100% CPU usage in the network message handling thread of the node. So Bitcoin Core has one thread that's handling all the messages between peers, and there we had like 100% CPU usage. To dive deeper there, I did something that's called a flame graph. So I recorded where the time is being spent, in which function the time is being spent, and you read flame graphs from the bottom to top. So and the bottom is a function you're spending more time in than in the top functions. And here in the bottom function called, or in at least this is a thread called bmeshand. So it's the message handling thread of Bitcoin Core, talking to P2P clients and so on. We were spending 82% of our time, and then in a function called mayKeep, I wasn't aware of what this is and what this does. We were spending 64% of our time, and then in this obscure CTX mempool compare depth and score, we were spending 31% of our time. And I didn't know what CTX mempool compare depth and score does. But I asked the question, does the high CPU usage cause us to fail to respond to our peers in time? Because we were spending so much time in this compare depth and score function, maybe we can't respond to pings and pongs and other messages in time. And to add to the extra confusion, there was an issue right around the time, so May 6th, there was an issue on the Bitcoin Core repository called CPU DoS on mainnet in debug mode. But I was pretty sure I wasn't running my nodes in debug mode. And it turns out there were two issues at the same time, and we both were being discussed at the same time, and this caused for a bunch of confusion. It took a few days until we figured out that it's actually two separate problems, and I wasn't running my node with a boost multi-index enable safe mode, which slows down your node, or did slow your node down to a point where it actually couldn't process any transaction into the mempool. But different issue. At some point, we noticed this is probably network-wide. So a fellow developer wrote an IRC. I'm seeing this now too in my node, high spikes of CPU usage with compare depth and score being the main cause. So at the time I was running only 1 or 2 nodes, and I was seeing it only on one. And then it was really good to get confirmation of other people seeing this as well. There was one guy on a GitHub issue saying, hey, I'm seeing this out also, but PS I'm not running in debug mode. So he said, okay, there is definitely an issue there as well. And then a few days later, an employee of Antpool came around, so a big mining pool in Bitcoin, and said, hey, we actually have this in our mining pool as well. And I spoke to a few other mining pools, and they also have the problem. And it could be causing delays in like propagation and forks for us. And yeah, looking at the effects on the network this had, here in orange, we see the time it takes for 90% of the network to announce a block, and in blue we see 50% of the network, the time it takes for 50% of the network to announce a block in seconds over time. And we clearly saw the propagation delay spiking on these days where we also had seen this block. Similarly, one thing you can look at is the time it takes for a node to respond to a ping. So in the Bitcoin protocol, there is a ping message, and the node should respond with a pong. And you can compare the time it takes for the node to respond with the host of the node, the IP of the host of the node, to respond to like a normal ping you type on your command line. And if these diverge by a bunch, then you know there is something wrong on the application side, so in Bitcoin Core, because it can't process the messages fast enough. So we saw on the same dates, so around May 7th or May 8th, we saw a big spike there as well, but also a bit of elevated ping times before. And Antpool was right. We definitely did see stale blocks happening on the network just because the propagation of the blocks was affected. So we saw 10 stale blocks in the week between May 3rd and May 10th. And normally we would expect on average to see 1 stale block. So it was definitely like a 10-fold increase. Definitely something unusual. Let's get into the cause for this. So normally, if you want to relay a transaction on the Bitcoin network, you as us here in the graphic, you send an inf message, an inventory message. And in the inventory message, there are the WTX IDs of the transactions you're going to announce to the peer. And if the peer doesn't know about a transaction, it sends back a get data message. So it's saying, hey, please give me, for this WTX ID, please give me the transaction. And then you respond with the transaction. And to keep track of which transactions you need to announce to a peer, Bitcoin Core keeps an inf to send set of transactions, or of transactions to inf. And when you receive a new transaction, you're adding the transaction to the set. And when the peer tells you about, this is important, when the peer tells you about a transaction, it already knows, you remove it from the set. So the sets get smaller because both of you are going to announce back and forth. The set is unbounded in size, and there is like a warning sign here. Obviously, like unbounded in size is for something that's accessible via the P2P network is also a bit critical, and the set was drained at a fixed rate. Then we're going to sort the set periodically, so every 5 seconds, for example, we're going to sort the set with the CTX mempool compare depth and score. So we saw this function earlier, we spent a bunch of time there. And we sorted by transaction dependencies and fee rate. So we want to make sure the transactions that have a higher fee rate, for example, are infed earlier, just because they are probably also going to be mined earlier. So relaying higher fee rate transactions to miner earlier is better. And This also helps us avoid leaking the order of which we receive the transaction, because we're going to sort it. So it's not depending on the order we received it. It's a different order. This is a nice privacy benefit. And then once we sorted these sets, we pick out at the time 35 transactions from the top, or up to 35 transactions from the set, and send them in an inf message to the peer. So what happens when transactions are broadcast at a higher rate than being drained? The set being unbounded in size means the set grows. And at some point, you're going to be either running out of memory because the set is too big, or the sets for each node are too big, or you're going to be spending a bunch of time in compare, depth, and score. And this is what we saw here in this case. But why would someone be broadcasting a bunch of transactions at the same time, right? That's quite inefficient. Probably spreading them out over time makes more sense. Also, who has like a bunch of transactions, like millions of transactions to broadcast at the same time? Well, there was something going on there, very like a hype topic. So BRC20 token mints were the big hype topic back then, and they were driving on-chain fees up. People were unhappy about it, but also they were sending out a bunch of like very small transactions at the same time. And for just this one mint being talked about in the street here, there were like more than 500,000 transactions being sent out in a very short time frame, and that's probably what triggered this bug. The bug was always there, but we never saw the amount of transactions being broadcast before. And then this bug was also amplified. So I told you the transactions the peer tells us about are removed from our set. But on the Bitcoin network, there is a bunch of spy nodes. So spy nodes only listen to infs. They're never going to announce anything to you, because if they're going to announce anything to you, you're not going to tell them about it. And they want to listen in on what you're going to tell them about it and when you are going to tell them about it. So the inf to send sets for the spy nodes, they were staying larger for much longer. So we also needed to sort them a bit more and need to spend more CPU time on them. And currently, a node usually has, if you accept inbound connections, you usually have like 10 to 20 connections from spy nodes. So the DoS was amplified by this. I didn't work on the fix for this, but AJ luckily did. I wasn't aware of how to fix this back then. I just looked at the code afterwards, and the fix was actually quite simple. So there was some inefficient sorting going on, and one easy fix was to drop transactions from the queue or from the set that already were confirmed, that are not in the mempool anymore, very early on. So no need to keep them around and sorting each time, because we are never going to announce them. So there was one bug there, or one improvement there, and the other improvement was just to increase the rate at which we drain these sets by looking at the size of the set, and if the set is really large, then increase the rate slightly and drain it faster. And as you can see, this fix was opened on May 10th and merged on May 11th, so actually quite fast. Obviously, people were aware this was going on. We were not too public about it, but yeah, Unpool, for example, like they noticed it, they were aware of it, and a few other people were aware of it as well. We just never like published, okay, there is something very critical going on, just because we never knew like what is the extent of this, and what can happen if more people take note of this. Maybe there is a BRC20 token mint specifically designed to take down the network. Who knows? And the fix was included end of May. The same month, end of the same month, and released in Bitcoin Core version 25. Luckily, there was a release candidate going on back then, and we could quickly backport the fix. So it actually didn't take a long while for people to fix this and running a release where this was fixed. Also, yeah, these BRC20 tokenments died down a bit, so not too much activity anymore. But it also made like testing this a bit harder because having or in some way generating like 500,000 transactions in a matter of minutes and broadcasting them is really hard. And that's also inspired some of the tools, simulation tools, you know. So many of you know Warnet, for example. Warnet was inspired by this bug because the idea is in Warnet you could, in theory, do this and test against this by having a node and blasting it with transactions. And then on my side, on the monitoring side, I was thinking, well, monitoring is one of the last lines of defenses before bugs reach the user. Obviously here, the bugs reach the users, for example, ANPRO being affected. Yeah, but I thought, what can we do about this? What can we improve? And monitoring is very often searching for unknown unknowns. So you need to collect more data, and you don't actually know what you're going to do with it in the future, and you hope to detect something. But a recap of bugs like this, so as we're doing right now, really helps for monitoring to define metrics and come up with ideas. Okay, how can we find this bug in the future? What should have we been tracking back then? And maybe even extend on the scope a bit and say, hey, similar classes of bugs, how can we find them in the future? What metrics to keep track of? And one of my tools is called Peer Observer. The idea is very simple. It's like run a bunch of Bitcoin nodes in the cloud or wherever, spread around the globe, and attach monitoring tools to them. And with the goal, a specific of the goal is to detect attacks and anomalies. So attacks, someone being malicious, and anomaly, there is a bug in our code, and we don't know, it's not behaving as we would expect, not normally. And one thing I did, or after seeing this attack, was one thing to improve the dashboard for this. So I have a specific dashboard for inbound connections over time. And this is very similar to the metric that led to the initial detection of this. And I run more nodes. So we have more nodes in different configurations, different locations. Maybe some of them don't have a mempool, so that they wouldn't be affected by this. Others are like very low-powered CPU nodes, so they are way more affected by this. And I've been very happy to receive sponsoring for some of these nodes. So, for example, Brink has been sponsoring some of these nodes. The MIT DCI as well. Vintium is sponsoring a node. Localhost Research is sponsoring demo nodes, so we can actually have this data live and accessible for everyone. But I still think this needs more and better anomaly detection and alerting to be able to detect this. Even if I'm not staring at the dashboard all day because I'm standing here and giving a talk. Another thing I added is thread monitoring, so monitoring how much time we spend per second in a thread. So doing this for all of the threads that Bitcoin Core has, but specifically for the B message handling thread, which was the one affected. So I look at, for example, if one node is spending a second in the B message handling thread, then we are spending 100% of our CPU time there. And two observations that stood out immediately is like a node with way more connections is obviously spending more time there because it has more peers and more messages to process, more transactions to inf, more pings and pongs to respond, and so on. So we definitely can see a node with more connections spending more time there, but also nodes with weak CPU, like only one core or two cores, definitely spend more time in there just because they are not as fast as the other ones. I also set up some local host ping pong monitoring, so doing the Bitcoin protocol ping and pong. So I have a P2P client that is connected to my node, and I'm sending a ping with instead of the nonce in the ping, there is normally a nonce in the ping. I just send a very precise timestamp and wait for the pong to arrive, and then measure the difference between these. Normally, this is like between 1 millisecond and 10 milliseconds, and really shows how much backlog there is for this node, because you process messages in one thread and you process maybe other messages from other peers first, and you only process one at a time. So it shows you how fast the node can work with the backlog of messages it receives over the P2P network. And then I mentioned the inf to send sets earlier. AJ went ahead and added to get peer info monitoring for the size. So we actually have an RPC to query the size of these inf to send sets. And two very useful metrics I came up with is the sum of the size across all peers. So it shows you how many messages, for example, are being sorted. Each whatever 5 seconds or so, and also looking at the max individual size of the inf to send sets. So for example, if there is a spy node, it's going to have larger sets than the normal peers, because the normal peers are like reducing the size by announcing transactions as well. So we have sets on these now as well. And then I showed the flame graph earlier. There is something you can do. It's called continuous profiling. What you do is you record each, I think using Parquet.dev here, Parquet.dev is recording where the CPU is spending its time like 19 times per second, and you build a flame graph out of this, and you have data over time, and can go back and say, hey, where did I spend my CPU time in these 10 minutes yesterday? And if you know there was an anomaly there, then you can actually go there and say, hey, let's see where or which function was the problem. And I don't think that is enough. I think there is still work to be done. Obviously, I can't do it alone. So I came up with the Bitcoin Network Operations Collective. So it's a NOC in a sense. So NOC in a company would be a Network Operations Center. I don't think a center is the right thing for Bitcoin. I think it's more like a collective of different people from different parts of the world working on different organizations coming together and discussing observations they had on the network. It doesn't need to be the P2P network. Can be other places, and we definitely need better automatic alerting and anomaly detection. I'm very glad there is a guy called DoS. He started working on this, and I think he is the right fit for this. So very much looking forward to what he can come up with this. And in general, I think we need more like analysts kind of people who look at dashboards and maybe react to alerts, who are familiar with the Bitcoin protocol and know, okay, this is something we should look into, or this is, yeah, okay, it doesn't really hurt. We can ignore it for now. If you want to check out the Bitcoin Network Operations Collective, there is a forum. It's bnoc.xyz. We also recently set up a chat, bnoc.zulipchat.com. Yeah, if you want to be a part of this, if you want to join or help out in some way, if this is interesting to you, feel free to come and stop by. There is definitely some activity on the forum. The chat is not too filled right now because we just set it up. Yeah, and while working on this, no. That's not showing my screen. Right, now it is. Great. While working on the slides for this, I actually looked at some of the metrics and posted them to the bnoc forum. And, well, I noticed the same bug happening again. It's not as critical, not as bad. But here I wrote, like, this is like 10 days ago, so I wrote in on the 17th, starting around I'm going, you see it in a second. So at around 1 a.m., 1:30 a.m. UTC, a bunch of my nodes actually spend a bunch of time in the bmessage hand thread. So red means bad here, green means okay. So there was definitely something going on. And then looking at my mempools, they all started to fill up at the same time, from around 6% to 60%. So there must have been some transactions being broadcast. Looking at the size of the inf to send sets, they also spiked to like 1.7 million inf to send entries across all peers on the nodes. And the individual ones also spiked to around 60 thousand. So we know, okay, there were like 60,000 transactions being broadcast in a very short time. Probably, who would do this? And we also saw the ping and pong times from, I already mentioned this is around 1 millisecond to 10 milliseconds, but we saw it spiking to actually like 1 second or maybe even 5 seconds on some nodes and at some points in the time. So definitely nodes were affected, definitely the network was affected by this, but only for a short period of time, which is where I think the fix comes in, that AJ did a while ago. So these IMSO sets died down way faster than they would have. So here we see them dying down in a matter of like an hour or so. And then looking at some of the transactions, it actually turns out there is like this uncommon goods rune thing going on. So a bunch of these runes are being broadcast at the same time. I'm not too familiar with this. I'm not too sure why they are being broadcast at this time. Maybe there is something like, I don't know, to gain from broadcasting them as fast as possible. Right. Did a bit more digging, and now the function isn't called compare depth and score. It's called compare mining score with topology. Just got renamed because also the way it works got changed a bit. But on the internet service, so on the Flame Graph, we can see that actually we spend like 20% of our time there. So maybe it's not 100% fixed, maybe it could even be improved. And then AJ said, yeah, I've been working on this or thinking about this. And he actually opened a pull request for this. There is even more improvements to be done here. And I'm very happy that the monitoring inspired this. And I think it shows that Bitcoin isn't done. There can be exploits, and you can be helpful in helping fixing these, and I haven't had the time to look at this in detail, but I think I will once I'm back at my desk and can work on things. And I think we now have a few minutes for questions. You can find the slides for this talk on my website btcplusplus.me/talks.
Good morning, great presentation. I have 3 questions, if I can.
Sure.
First one, how do you manage all this infrastructure? Meaning, do you wake up every day 5 a.m. and look at your servers? But because it seems that you have too many things to manage at the same time. How do you deal with it?
So I automated most of the things. I use NixOS, so I can. It's very easy to say. I'm not selling NixOS. I'm just explaining. Like, you can quite easily manage to say I want to have these servers running all the same software in this configuration. And for me, it's very easy to just say, okay, deploy everything, and I'm sure what's running on there. Have some alerting on, like, if a service goes down or so, I get a ping on my phone. But at this point, I have gotten it to a place where I usually don't get pings unless there's something going horribly wrong. Yeah, I think this is a way how I can do this as a one person team running like 16 servers and even more for different purposes, and having it quite stable. And obviously having infrastructure as code, you can also have tests for your infrastructure. So if you change something, it's not going to break on you, because you have a test that hopefully covers parts of your infrastructure you want to rely on.
Okay, next question is, I think you said a few slides ago that you have a well-crafted, especially crafted node for the pure observer with some metrics inside of it. How do you manage to observe the network without disturbing it? Meaning, you may be asking some P2P message to a node, and the node might ban you, and then you get out of the network just.
Right. So the decision I made for peer observer is for it to be fully passive. So it just behaves like a very normal Bitcoin node. it just has monitoring tools attached. So different interfaces. For example, we have something that actually someone here contributed, is like looking at the debug log of the node and extracting events from this, but also looking at the RPC interface, extracting events from there. There is a tracing interface I heavily use, so we can get all the messages the node receives and sends out of it. But I don't interfere with the node. The node should be like, I don't touch the node. The node should do its thing, and we want to see what the node does. But we're not trying to change the behavior, but because this would maybe give us false data. But I think there is in monitoring, there is definitely the possibility of doing active monitoring. So you actively connect to nodes, and you definitely send maybe messages in a certain order to get some data out of it. But that's not what Peer Observer is intended to do. It's more like we run a Bitcoin core node, and we want to make sure it's actually stable in the network, and we don't want to touch it in a sense that we run it maybe with a different configuration, but we don't interact with the peers or whatever.
Okay, last one. Why btcplusplus? Where did this name come from?
Oh, I just randomly typed in the keyboard, and this came up.
Nice.
Great presentation. I'm thinking, like, what if I want to run like a monitoring suite sorry, for like a local node? Let's say I'm testing something, and maybe this seems like too much infrastructure for like a local test, or like I do have like an idea about an attack, and I don't want to use it on mainnet, of course. And then like this monitoring suite, it would help me to like understand it better if it's really working. And is there like a local first version of what you do, or is it like your Nix configuration meant to be run on like a node that has only one purpose, and that purpose is monitoring like the mainnet, not
right. So my specific configuration is for the Peer Observer, like the running nodes in the cloud, and all of them piping data together and having a collective dashboard of this. But there is definitely a possibility of having some either like setup where you only have one node and one data collection thing going on, but this would then be dedicated for this, or just writing a different configuration, or just not even using my Nix configuration and just setting up something maybe in Docker or whatever, and maintaining yourself to a point where you can run this just against a node you have in whatever in your home or on your laptop or so. Definitely possible. It's just not my use case. So I'm not going to maintain the infrastructure for it, but definitely other people can. And I think Ideal's university also had some setup for their running this in Docker, so that they didn't use any of my Nix stuff, and they set up a Peer Observer instance, or at least the tools for it, in their university's servers without using Nix at all.
Hello, btcplusplus. It's a great presentation. My question is, this project Peer Observer, do you run many node versions or different implementations?
So it's currently only Bitcoin Core and software forks of it. So I run a NOTS node, for example, just to see how the NOTS node behaves against or compares against the Bitcoin Core node. Also like running Libre Relay or whatever. A BIP 110 node, it could be interesting just to see, okay, it actually behaves maybe better in some ways because it obviously rejects transactions. But also maybe there is a chain split at some point once it activates. So definitely interesting to monitor as well. So only Bitcoin Core and different flavors of it. But definitely running like different versions. So what I'm usually doing is running release candidates on this, but also releases. So if we release something, then I'm going to run it for a while. But also just upgrading to master over time and seeing if master is okay is really helpful. And on some nodes, I also run in like an older version because I may or may not know there is something vulnerability in there, and then we can see if there is someone exploiting it.
Cool, nice presentation.
Peer Observer makes a lot of data that you save. It's open to the public to use it for analysis.
Right. So the issue with the publishing of the data is, if I publish data, you can find out very easily what the IP addresses of the nodes are, and then an attacker can find out, or whoever, and either attack the nodes on purpose or exclude them from their attack. And that's not what I really want to do. So that's why I say, okay, I want to have honeypot nodes. So I'm not telling you the IP addresses, and that sadly means some of the data is not available right away. It probably needs to be analyzed, or anonymized a bit. So stripping IP addresses and maybe only publishing it after a year or so once I rotated the IP addresses. But luckily we have localhost research stepping up and saying, hey, we're going to sponsor 2 nodes. And these are fully demo nodes. These are all public, and people can connect to them and look at all the data. It's the same setup as my Peer Observer thing, just with the caveat that there might be people finding out these IP addresses and doing weird stuff to them. But it's useful, very useful for developing against. So you don't need to run your own, like, whatever extractors I use for Peer Observer. You can just hook into the message feed yourself and use it there. And also it shows, like, to the public what's being monitored, and people can click around, maybe even learn about stuff, or come up with new stuff to monitor. Yeah.
Thank you.
Just a quick question. I really wanted to know if you think protocols like runes or the ordinals have something related to those spikes that you are seeing, because they tend to have like off-chain recurses that do batching, and they execute mostly in the same time window, just like you showed to us, that like it's a spike that occurs during 2 hours in the day and then goes out. So I guess it might have something to do. I don't
Yeah, definitely has something to do with it. Sadly, I'm not familiar enough with the runes or the inscriptions. But if someone knows and can explain to me why they need to be broadcast in like a very short time frame, or why they're doing it, I'm very happy to learn about it.
Yao would consider it like over abusing the UTXO and the Bitcoin network to do stuff like it, like, or are you planning to improve the network to support those type of protocols? That require lots and lots of requests, like a gaming protocol or whatever, you know?
Yeah, I'm not sure I fully understand it, but I think not even thinking about like obviously ordinals or inscriptions or BRC20 documents or runestone mints is one way we're seeing this, but obviously if there is a bug there, we should fix it regardless, not saying, okay, we're fixing this for ordinals or whatever. We should fix it regardless, because there could be someone who's not doing this out of hype around the thing, just someone doing this because he wants to attack Bitcoin. And I think if you have sufficient funds, you can actually sustain an attack like this over a span of days or weeks, maybe even, just by sending out very small transactions and attaching, obviously paying a fee for it.
Yes.
But this might be the cost you want to pay, and just to break Bitcoin. Yeah.
No, I think you got it. Yeah, that's
cool.
exactly it. Yeah, thank you.
All right. Thank you.